Next, we're going to take a look at optimizing volume and surface areas. If you have a rectangular prism with a given volume, a cube will have the minimum surface area. So let's look at what that means for our formulas. Recall that the volume of a rectangular prism is length times width times height. So if the length, width, and height are all the same, then the volume is just the length times the length times the length. And we have that the volume is the length all cubed. Now for the surface area, we know we have two sides that are length times height, plus two sides that are length times width, plus two sides that are width times the height. And again, considering all of them are equal to L, then we have L squared plus L squared plus L squared, length times length plus length times length plus length times length, which gives us 2 times 3L squareds, which equals 6L squareds, which makes sense. A cube has 6 sides of equal length on each side, so the total surface area is 6L squared. So we're going to use these formulas to help us with the following examples. So Mel constructs a rectangular prism with a volume of 64 centimeters cubed and has a minimum surface area. What are the dimensions of the prism? So for part A, a cube is going to give us the minimum surface area. And we know from above that the volume is equal to L cubed. So since our volume is 64, and that's equal to L cubed, in order to find the length of each side, we're going to do what's called a cube root of both sides of this equation, and we'll end up with a length of each side equal to 4. You'll need to find your cube button. So on my calculator, I typed in the number 3 for the cube root, and I found the button that looks like this, an X with like a square root symbol. I typed in 64, and then I hit enter, or equals. So you'll need to find this button on your calculator. You may even have a cube root button on your calculator. So what are the dimensions of this prism? So for part A, the dimensions are 4 by 4 by 4. Part B, what is the surface area? So again, we're focused on a cube since we're looking for the minimum surface area. This is going to equal 6 times L squared, and we know that L is 4, so 6 times 4 squared, which gives us a surface area of 96 centimeters squared. So therefore, the surface area is 96 centimeters squared. All right, next type. We have a rectangular prism with a given surface area. So if you're given a certain surface area, a cube is going to give you the maximum volume. So since we're dealing with a cube again, here are the formulas we're going to use. So we have a surface area, we would call it 6L squared for a cube. And the volume of a cube is length times length times length, so it's L cubed. So we're going to use the same two formulas when finding the maximum volume. Mike constructs a rectangular prism that uses 384 square feet of material, and we want to get the maximum volume. Part A, what are the dimensions of this prism? We know it's going to be a cube, and we are given this time the surface area, so the surface area is equal to 6L squared. So we put 384 into our surface area, and then we need to solve this equation. So this one involves 2 steps. The first one is divide both sides by 6, which gives us an L squared equals to 64. And then the second step is to square root both sides of this equation, and we get that L is equal to 8. So that is going to be the length of each side of this cube. So what are the dimensions of this prism? So the dimensions are 8 by 8 by 8. Part B, well, what's the volume? Since we're dealing with a cube, we know the volume of a cube is equal to L cubed. From above, we have 8 for our length. So the volume is equal to 8 to the exponent 3. So on your calculator, you're going to have to find your exponent button. So it might be like this. You have 8. Some of your exponent buttons look like this, and then you can type in 3. Or you may have a y to the x or an x to the y button. So you'll need to figure out which one works for you. If you've done this right, you should get a volume of 512. So therefore, the volume is 512 cubic feet. And that's optimizing rectangular prisms. One with a given volume and one with a given surface area. Please try the following questions.